Having learnt proportional variables, proportional operators, consider this argument if I work hard, then I score grade S. I do not score grade S. Therefore, I am not work hard. Something like this is given to us. I do not score or I did not score grade S, therefore I am not worked hard. Okay. So an argument like this, you can look at it this way. This is a proposition. Scoring grade S is another proposition. So together, this is premise and this is our conclusion. So what is that we want to know? Does premise implies conclusion? Meaning, translate this into logic. P implies Q precisely represents the first statement. In a logical argument, you have statement number 1, statement number 2, then how do you combine them? Using AND operator. I make sequence of statements, which means one after another. How do you combine them? Using logical AND. Then I do not score or I did not score grade S, then it is negation Q. Q represents scoring grade S, negation Q represents do not or did not. Okay. This implies, what is our conclusion? Therefore, I am not worked hard. So this is our natural language text, and if you transform to logical expression, we precisely get this. Now we want to verify this. Verify whether this implies this or not. Okay? How do you do it? We can do it using truth table. So let's look at PQ. Possible values for P and Q are true, false, false, true, false, false. The first one says P implies Q, then it is true, false, true, true. Next one says negation Q. Negation Q is false, true, false, true. Then combine these two using the logical operator. Then this is false, this is false, this is false and true. Next one is negation P. Negation P is false, false, true, true. Then what is that we want? Let me assume this to be X and this to be Y. We want to know whether X implies Y or not. Correct? Now, FF implication says true, 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 true. Now, when you see that X implies Y is true everywhere, which means given argument is true, given conclusion follows from the premise. the given argument is indeed true, it is logically implying this given this. These are all some of the statements that one can make. But formally, you look at the truth value of this expression. If the truth value of this expression is true for all possible values of p comma q, then the expression is true, or given argument is a valid argument. And this becomes an identity, meaning in a context you get to see this, and this implies this. So in a context you see this, one can always conclude this. It becomes an implication. So this becomes an implication. What does that mean? If P implies Q and negation Q, because now the if that I am expressing is for the entire thing. If P implies Q and negation Q, then you can conclude that it is negation P. Alternately, if this appears in an expression, replace it with negation P. So we wish to explore expressions of this form, implications of this form, so that a given logical argument can be simplified with the help of known implications like this. This is just an example. It motivates us to bring this abstraction, and subsequently we were able to conclude this. This is precisely what I shall be focusing on throughout this course. Take an example and extract a larger message, bring the abstraction, then focus on the abstraction. Then learn more on the abstraction. Now come up with some more expressions, some more conclusions, and see which are implications true, which are implications false. And so that when you start working on a larger problem, a larger argument, such implications will come handy. You can start plugging in them to simplify the given logical argument. More on this we shall discover now.